All right, today's section is on 2.5, solving problems with composition. All right, so when we're done, you're going to be able to identify the domain of composite functions. Now, before we do that, we're going to have to do a little warm-up in order to help you get a skill down that you need to do this. So here we go. Here is a, well, that's not it. Where's my warm-up? Right here. All right, so go ahead and either do this with me, write these problems down, or I have a worksheet that you can come on up and get up here. So either way, if you don't have the worksheet, you can just look at these. Okay, and we're going to go through and talk about how to solve inequalities. Well, remember you solve inequalities the same way you solve equations. So if I was going to solve this for v, I would just have to get v by itself, which means in this case I would add 9 to both sides. Okay, and that gives me v is greater than negative 12. Okay, that's how easy it is. So you solve an inequality just like you solve an equation. So over here, to solve for x, just subtract 20. So you get x is less than or equal to 16. Now the thing you have to remember though is in an inequality, when you multiply or divide by a negative, and it's going to affect this problem right here. If you multiply or divide by a negative in an inequality, you need to change the direction of the inequality symbol. So in this case, let's just look at this. If you were to solve for x, you'd say, okay, well, I need to move that 13 over, so I'm going to subtract 13. If you look closely, you end up with negative x is greater than negative 18. So right here, this negative x, this is a problem. This is like a negative 1. So I'm going to have to divide both sides by negative 1. That gives me x, and it gives me 18. But because I divided by a negative, I have to change the direction of the inequality. So my final solution to this inequality is x is less than positive 18. Okay, and just to kind of talk about why this works, do you agree that 4 is less than 8? All right, well, what happens if I divide both sides by negative 2? I get negative 2 and negative 4. Is negative 2 still less than negative 4? Well, no, if you think of money or the number line, actually you have more money if you have negative $2 than if you have negative 4. So in inequalities, this happens with multiplying and dividing by a negative number. If that happens, the value of the inequality does change. All right, so let's look at a few more of these. If you have the worksheet, I'd like you to just do them on your own. Go ahead, do them on your own, and then you can pause the video, pause this, and check your answers and see how you did. So for number 4, there's not going to be any negatives here. We're just going to add 12, and we'll get a is less than 1. Number 5, we're just going to add 20 to both sides, and that will give us n is greater than or equal to 0. Didn't have to change anything. And all of these next 3 I can tell because the variables, there's no negatives there. So they're just going to be simple, okay, subtract 8, subtract 8. So k is less than or equal to negative 13. Add 13 here. You get p is less than 16. Subtract 16. So x is greater than or equal to 12. And then these last 2 is where you're going to want to practice your changing the inequalities, because you're going to have to add 5 here. But again, be careful. You get negative n is greater than 1. You can't have this negative n is like a negative 1n, so we've got to divide both sides by negative 1, which means we're going to have to change the direction of the inequality. So you should get n is less than negative 1. And then over here you'll add 16. So negative m is less than 13. Divide by negative 1. And you get m is greater than negative 13. All right, so that's kind of our warm-up that you need to do in order to be able to do the problems in this section. All right, so you're going to be able to identify the domain of composite functions. So again, either print this off on Apex or come see me and get the checkup, the practice problems. And what we're trying to do is here in this section is find the domain or find the input for composite functions, g of f of x. So if this is g of f of x right here, we want to know what values can be in the domain. And if you remember what domain is the input or the values you can put in. Now, there's two things we're going to have to talk about here. The first thing is that what can we input here? For a square root, what numbers can you have underneath a square root? For example, the square root of 25, a positive number, that's 5. So you can have positive numbers underneath a square root. You can have even 0 underneath a square root. But do you remember certain numbers when you use your calculator, you take the square root and it says error? What kind of numbers give you error messages? Well, whenever you have a negative underneath the square root, you cannot take the square root of a negative number. There's no number times itself that will give you negative 25. You say, well, what about negative 5 times negative 5? Doesn't that equal negative 25? No, a negative times a negative is a positive. So when we're talking about what values can be the domain for g of f of x here, what we're looking at is setting up an inequality. Now you can see why we did the warm-ups. X plus 1, that value underneath there, has to be greater than or equal to 0. It has to be positive. Okay? So in order to find the domain for this problem, for all of these problems, you're going to have to set up an inequality, which is why we did the warm-up. So this should be from what, if you understood what we just did on the warm-up, this shouldn't actually be a big deal. So x is greater than negative 1. So the domain for g of f of x here are all x greater than negative 1, because if it's anything less than that, you'll have a negative underneath the square root. So the same thing here, you've got your variable, your x, underneath a square root sign, and that can't be negative. So all the values put underneath there has to be greater than or equal to 0. So the domain for this problem is all x greater than or equal to 4. Now, when you get to a problem like this, this 5 does not affect anything. This 5 is not an input value. Just the x is where you're going to be putting values in for. So you only have to worry about the x plus 3. So just pretend that 5 isn't there. And again, x is just all numbers greater than or equal to negative 3. So that this value under here, right here, will never be a negative number. All right, so when you get to problems 4 through 6, you can see that we're going to have, they're all just numbers underneath the square root. Here, x is underneath the square root. Here are the variables underneath the square root. Here, the variables underneath the square root. We don't have to worry about the 2 here or the 4 here on number 5. But the problem with these is, which is why I went over this, again, that value underneath there has to be greater than or equal to 0. But when you go ahead and try to solve this and you subtract your 2, you get negative x is greater than or equal to negative 2. So when you divide by that negative 1, what happens is you have to change the direction of the inequality. So x can be any value less than or equal to 2. All right, so here 10 minus x has to be greater than or equal to 0. Subtract 10. So negative x has to be greater than or equal to negative 10. Divide by negative 1. So x is anything less than or equal to 10. And for this one, negative 4 minus x has to be greater than or equal to 0, again, because it's underneath a square root. And we're just kind of doing that same thing where we're going to end up with a negative x and we're dividing by -1. So we're going to have to change the direction of the inequality, and that's a -4. So most of the problems when you get to the quiz, you just have to be careful and look to see, what am I dealing with here? Now all the ones so far, even including this one, number 7, this 1 doesn't matter here because there's no variable with that. All that matters is what's underneath the square root has to be greater than or equal to 0. So add 4. So x has to be greater than or equal to 4. But the other type of problem you'll see is this one, like number 8. The variable here now is not underneath a radical, it's in the denominator of a fraction. And who remembers what value you cannot divide by in math? Or again, you've done this maybe on your calculator, you get an error message. Or you know that when you're graphing lines, if there's 0 in the denominator, we say it's undefined. I kind of just gave you the answer there, sorry. You can't have a 0 in the denominator. So this x plus 1 cannot be equal to 0. So that's the equation you set up to find the domain, which means solve the second equation, subtract 1. X cannot equal -1. So x, the input or the domain, is all numbers except -1. All right, so if you turn your page over or just look at these with me, these are similar. These problems finding g of f of x, what happens here though is we combine the square root with the value in the denominator. So instead of just saying here x plus 6 is greater than or equal to, hang on a minute, x plus 6 is greater than or equal to 0, we can't have this or equal to because it's in the denominator. We can't have the denominator be 0. So instead we're just going to say x plus 6 is greater than 0 and solve that. So x is going to be all numbers greater than -6. And again, when you take the quiz, they're going to fool you. They'll have or equal to, and I've gotten that wrong many times when I'm helping students and forget, oh yeah, that's right. Not only is it underneath a radical, it's also in a denominator, so it can't equal 0. So the same thing here, this 4 minus x has to be greater than 0. We can't say or equal to because it's in the denominator. Subtract 4, and this is going to run us into that problem where we have a negative x. So that's okay. We're just going to divide by -1. So x is less than 4. So the domain there is all values of x less than 4. So the goal for today was to identify the domain of composite functions. And that's exactly what we did on these problems here, where we're trying to figure out what values could we use for x here. Okay, we got to make sure that they're greater than or equal to 0 because they're underneath the square root. Or the other case could be where our values were in the denominator, and we can't have numbers in a denominator equal to 0. So you're just going to go to your quiz. They're going to give you different questions, and you're just going to set up equations that either have an inequality or maybe say that it's not equal to 0. But if you've done the warm-up and you've done this checkup and you feel confident that you understand what's going on, you can go to Apex and take quiz 2.5.3. If you have questions, make sure you come and see me.